Hi, welcome to the talk upgrading custom applications from EL8 to EL9 and at some point EL10, 11, 12. As long as people are paying me money, I'll doing the same. By the way, I'm Evgeni. Hi. I've been doing this for a couple of years now. Currently a software engineer at Red Hat and enjoying it. So here I am. In my previous life, also at Red Hat, I was a consultant. And at that point, one of my customers said to me, we don't trust those expensive servers to run Linux on them. Even so, for me, it was good. I was paid for it because of that. But they didn't, because they were producing a product and the machines were running their SAP and whatever, but the Linux was just commodity for them. And this stuck pretty much to me because it was like, yes, it's pretty true. You want to have your system running and your application on top because the application is what you care about. Linux is nice, but not what you're earning your money on. So, and with that, we come to the problem that while the application has one life cycle, the operating system has probably a completely different life cycle, and we need to somehow juggle those and synchronize them, right? And to keep my system secure, I need to have my operating system as latest as possible and also like my application. So how do we do that and what challenges do we face here? The natural answer to those problems is, oh, let's just take my application and redeploy it on a new machine. Just running the new OS server, OS version, right? It's so easy. And it really is easy if you have like a stateless application, like an Nginx or a HA proxy, which is like just doing something. Maybe it's a worker that does computation for you, but it doesn't have any state locally, really. Maybe a certificate, but still not really much. It also works for like machines that I call like single state, like a PostgreSQL, right? It has everything in valid PostgreSQL. You can move it to a new machine, and the amount of work needed to get it working is pretty nicely sized. If you're operating a PostgreSQL machine, you know what you need to do with that. So you can do that. Luckily or sadly, I don't know, I'm being paid to making things more interesting in setups where it's not that easy. And Foreman is one of those systems where like we have state all over the place. Obviously we have PostgreSQL because we need to store data, but we also have pulp storage, which is somewhere on disk. We have, as we have just seen, TFTP data that is also stored on disk. And if it vanishes, your machines won't boot anymore and you cannot redeploy them. So hell breaks loose. There are more things like Puppet modules and Ansible collections are also stored on disk. And if you do not save them to the new machine, you need like to know that they're gone and redeploy them. If you take a full backup of Foreman, our backup solution takes care of it, but backup and restore is not always a solution. I'm sorry. So we need to talk about like what's better. Obviously, people who are used to Debian, they just say, yeah, okay, cool, I'm just going to do this upgrade. And you're right, that's how Debian would do it. And you just go edit your sources, you upgrade, and in most cases it works. On Fedora, you go and take DNF system upgrade, which is just slightly smarter than replacing sources manually because it can do it for you. And it will do it in a live system just to be sure that all servers and everything is down while doing the upgrade. And for enterprise Linux, because that releases every 5 years, we have this tool called Leapp, which also, again, it codifies our upgrade. And it does this because jumping 5 years and sometimes even 10 years of like distribution changes and evolution can often not be easily just codified in RPM or package relationships. And also, if you try to do it like in post-installation scripts, they get messy. So Enterprise Linux has this tool which like it's a huge repository and contains code that knows how to translate a configuration on EL8 to 9, etc. And I think like if you ever did Ubuntu, they have a tool that's called do release upgrade, which is similar. It does a few preparation checks and it does the replacement of the system with like knowledge about the change. But, and you come to the important but, it's still just the OS. The tool doesn't know about your application, right? It knows about the application that comes with the OS. So I don't know, Bind or Nginx probably covered. But who is here in the room so lucky that your application is shipped as part of Space OS? No hands. So yeah, we need somehow to go slightly further than that and enable the upgrade to know about our application, because in reality, that's what we care about, right? So you probably see more of those just slides, and I hope you hate this word as I do, because it's never just something. It just will be more and more and more things coming there after somebody said it's just a tiny bit of change that we need to do here. So let's talk about what does actually just US mean, right? Given that the authors of the operating system and also the tooling that's for the upgrades, they don't know what your application looks like. So they're also not testing any workflows that involve your application. They're only testing the OS upgrade, and that will work. That's what the vendor will sell you, and what they're like expecting your money for if you're paying. And if you have your application package and it's installed on the machine, it might be just get removed because there are like unmet dependencies. And maybe it will not get uninstalled because you just dumped it in opt whatever, but it will actually not work anymore because, again, broken dependencies or the dependencies are now more secure maybe, and your application isn't up to date. I don't know, but lots of stuff that can go wrong. And we are here to fix that, hopefully. So yeah, what do we do? Sorry. What do we have to do for that? If we have a tool that can orchestrate the whole upgrade process of the OS, we need to go and extend it with our application. And that's what we did for Foreman and also for Satellite, for Enterprise Linux 7 to 8, like 4 years ago. And now again with 8 to 9. And this is like kind of the example what we had to do and what we had learned from this experience, from this 2 runs of upgrading applications. And yes, Satellite is also by Red Hat, but the Red Hat like base OS team, they don't care. They don't have the capacity even to care for Satellite upgrades. So we have to do it ourselves. But obviously, before like going to the upgrade part of the thing, we need to cover prerequisites. Sounds obvious, but we need the OS to be actually upgradable, right? If there is no upgrade path from 8 to 9 for the OS, our application cannot be upgraded in place, right? We can still do a redeployment, but that comes with different problems. And we need our application to run on the new system first. This will often uncover challenges on the new system. For example, Nofar was talking earlier today that we had to port to a new Ruby version. That one of the triggers for that was we need to run on a new OS that comes with the new Ruby, and it's getting longer support. But also one thing that I would recommend, besides doing like this basic, like try it out, we need to plan ahead and plan to avoid some certain things. One of those is you need to avoid change, or at least unnecessary change, right? If we have a PostgreSQL upgrade, don't do it at the same time as the OS upgrade. For Foreman, we had to do it like on EL9, we have PostgreSQL 13 as a base PostgreSQL. So we prepared the PostgreSQL 13 upgrade first on EL8 in the previous Foreman version. So you would upgrade to 13. You have your running 13 working on EL8, and then you just need to upgrade. So you have no data migration for PostgreSQL. But we're not so lucky on the previous upgrade from 7 to 8. There were like problems. I'll talk about those later. Puppet upgrades 7 to 8 is not that hurtful, but still, if you can avoid it, do it. It's just cheaper to do the upgrades at a different point and focus on the upgrades of the OS that you have at hand. And yeah, any other non-critical upgrades. Like we can't avoid the Ruby upgrade, cool. But if you can avoid PostgreSQL or Python or whatever, do it, because it will be easier for us later on. So that was slide 10, and I didn't even talk about Leapp that much. It's good, I guess. So did anyone here already use Leapp in the past? Okay. You did? Really? So super simple, and don't look at the linked workflow that is in the slide later. How Leapp works. It has an analyze phase that you run with the Leapp pre-upgrade command. It will essentially scan your system, and after the scan has happened, it knows a lot of things about your system, like what repositories are enabled, what packages are installed, what services are configured, what configuration is in the services. Like, I don't know, I think, for example, one of the things that I've seen this time around is if you have firewall D, there's a change that something moves around, and the configuration from EL8 wouldn't work anymore in EL10. So it warns you if you have this one line that's breaking. You just need to uncomment it because it's not that useful anyway, but you need to do it, otherwise it won't be working. So this happens in the report phase. Like it collected things and it reported to you. And the report has like a summary. Either your system looks upgradable or you gotta fix a lot of stuff, right? And this is like a circle. You let it analyze, try to fix things that it reports, and at some point it will tell you, yes, your system looks like it's upgradable. And then you go and say, oh, okay, do the upgrade for me. And it will do a couple of things internally and boot your machine, and then you're on EL9. If you ever worked with Leapp, you will know that this is not as simple. So this is like slightly more complicated version of it. The upgrade happens actually in 3 phases. The first phase is the preparation of the upgrade, where you're still running your old operating system. It downloads all the packages it needs. Probably does a lot of things with secure boot. I don't know how they handle key changes between operating system versions. But the end of this preparation is you have a live system that you can later boot, and this live system contains all the information that's needed to upgrade your system. So after it's prepared, the machine gets rebooted, and you have this main run phase that replaces all the RPMs on your disk. And also does file operations like replacing files and stuff, like replacing configuration files, adjusting them if needed. What it does not do, and this is why we have this third phase, is it's not booting that operating system yet. So you're like this live image generated thingy that's intermediate. So you have no services running. So you cannot, for example, perform a PostgreSQL migration if you need data migration, actual data migration. Or you cannot run the Foreman installer because it would try to start services and services are blocked from starting. This is what you can do in the first boot. And this is where the machine comes up and it's like, it's already the new system, but there's like still artifacts from Leapp there because it knows that it needs like to finish up the upgrade. And this is the most like, there is a very nice overview of all the steps on the Leapp website, and it does not fit this slide, so I left it out. Because like the granularity inside of the Leapp code base is much higher, but it's not necessary for further understanding today, hopefully. So, but the important part is each of those steps can be enriched by you and me and everybody by writing own Python code. This Python code is are actors that you can inject into Leapp, and you can tell at which phase you want to run them, and the code then can do something for us. And the next slides, you will see the actors that we developed, and you would probably do similar if you have a custom application that cannot be upgraded by just upgrading the RPM. So the very first one, and forgive me the satellite naming, but that's what pays my bills, and that's fine, right? Each actor starts with kind of a preamble that has three things in it. It has a consumes line, and consumes is everything that must have happened before my actor can run. Those are messages essentially that Leapp actors can consume and emit, produce, that you see in the next line. And this one, it expects the installed RPM and the used repository things to be already generated. So because I need to know what RPMs are installed and what repositories are enabled to change them later on. And to do so, I also have like a produces part. This is what my actor will emit later. And I have tags. Tags are there for placing my actor in one of those phases that I've shown later. And forgive me that it says facts phase, because as I said, there are more phases than just analyze, report, and upgrade. But for our sake, it's just facts and analyze. That's the same thing. So what does it do under the hood, right? You've seen it consume installed RPM things. And based on that, first thing it checks, is there a Foreman or a Foreman proxy RPM? If there isn't, this is not a Foreman system. I don't care anymore. I can just error out or jump out with a success, nothing done code. I also collect information about the system, and especially like the Foreman part of the system, right? Which plugins are installed, because some plugins might need additional handling later on. Is PostgreSQL installed locally, or is it used remotely, etc. This all produces a message that's called satellite facts. And my later on actors will depend on the satellite facts message. If it's not there, again, it's not a satellite system or a Foreman system, I don't care. Those actors won't be ever executed. And if it is, they can act based on the data I have codified there. It will also, part of the produce step, generate RPM transaction tasks message, which essentially says which RPMs need to be uninstalled, which RPMs need to be installed. For example, when upgrading from EL7 to EL8, we had to move out of SCLs to modules. So this was a message that was saying, remove everything that has this funky TFM-something prefix and install all the packages with this prefix removed. Like 2 lines of code, but something had to do it. And if it's a satellite system, we also emit a repository setup thing, because there we can actually say, oh, it's a satellite running on EL8. Perfect. Replace the 8 with a 9. That's the repository you need for now, since now. And this only works for RHSM repositories, and that's why we are not using that for Foreman. So I mentioned satellite facts here. Under the hood, Leapp calls it a model. I always see it more as a message because it's like passing around, but the reality is data-only class, and you can say like, I have satellite facts, and one of the facts is, for example, local PostgreSQL, or it's Catello-enabled system, and not only Foreman only, and stuff like this. And yeah, it's produced by my very first actor that collects information about my system, and then all the later on can consume it and learn, like, don't have to re-evaluate the system, and also technically aren't allowed to re-evaluate the system, right? Technically they obviously can, but it shouldn't. So yeah, we store plugins, PostgreSQL information there, and that other things work based on this. Next actor that we implemented at some point was the upgrade services one. And this like kind of relates to the fact how we orchestrate the upgrade. We have the installers that will fix all the configurations that might have been broken since 8 to 9. But for that, we need the installer to run. And we do not want to start services with a possibly broken configuration. And because our installer can only run in this first boot phase, we need to disable services first. At some point in the past, this was a more complicated actor, but luckily Leapp learned to have a systemd services message, where you can say, those services I want to have enabled, those services I need to have disabled, and don't need to do RM, RF in etc. That was rather ugly. So yeah, it consumes the facts, and now it emits this nice systemd services thing, and it's running in the facts phase because we can do that early on, and the RM RF thingy would have run in the run phase, so in this init RD, because file operation is something that you can do there. Luckily, we don't have to, so it's easier, and technically we could even merge this one with the first. We didn't. We're lazy. So yeah, I already said that we need to upgrade, yeah, and we will do this. So the next one, which is luckily not used these days, is the upgrade check. This is the one that emits a report. And as I mentioned earlier, PostgreSQL upgrades can be messy. And in the upgrade from EL7 to EL8, we had to move around the PostgreSQL data from the SCL repository to the non-SCL repository, SCL var directory to the non-SCL var directory. And it was a pain, and we had to figure it out and tell the user whether we can or cannot. This is why we have this check, and it runs, again, it consumes the facts. it emits a report and it runs in the checks phase, which I'm more called the report phase because that's what the user will see. And it would go there and look at the facts that we generated earlier and see, is PostgreSQL like on an own partition? And if it is, moving it to the other directory would say, I need more space, or the same amount of space there. If there's not enough space, emit a warning, no, emit an error to the user. Otherwise, only emit a text like, yeah, we're going to move it. Better know that things have changed. I think nobody ever read that informational thing, but people were very aware if things would not move properly. But yeah, that's why I said earlier, avoid PostgreSQL changes by all possible means if you can do it. Right. The next actor that we had to implement was it's called data migration. Luckily, here is this is the one that would actually move the data for PostgreSQL. So it consumes facts, doesn't produce anything because it only does some action itself, and it runs in the application phase, which is the run phase here for us. It was only needed for 7 to 8, so luckily it still exists because the code still exists, but we don't have to run it today because the data doesn't need to move. It was pretty good when we realized that this is a thing that's not happening. The next one was the actual upgrader. If everybody's working with me on the team, they know I'm bad at naming things, so upgrader was the thing. It consumes the facts. It again doesn't produce anything because it's like the last thing that happens, and it runs in the first boot phase. And it does two things. It starts a PostgreSQL to re-index it because if you change the operating system, your libc changes, and PostgreSQL indexes are bound to the locales that are coming from libc. They're changing that. So I think PostgreSQL 15 plus can use UCI locales, and they are differently broken, maybe? People are nodding. That's not good. But yeah, re-index the database. Better one more than less, anyway. And then run the installer, which will examine all the configuration files on disk, and because it's Puppet and it now sees an EL9 system, it will override everything with EL9 compatible configurations and start our services, and we're done. So that means what did we have to do? We had to write 5 actors to the whole thing. Even so, we can X 2 of them because they are specific to the old setup, and hopefully we will not have to have that again. And we could have refactored one of them, so actually like 2 actors. That's not that bad of a thing. But, and I think this is one of the main takeaways that I wanted to have, is this was only possible because we took quite a few shortcuts. And it would not have been possible if your application architecture is different. We have the installer that takes care of a configuration, so we don't have to codify that part in Leapp. If your application doesn't come with an installer, which might be a good thing on its own, you would have to do that in Leapp or in some other way of configuration management. You probably could hook up Ansible or so into Leapp. I don't know. Might be an interesting topic to explore on some weekend. We didn't have to migrate data. That's good. Because we were prepared. We knew that we can't have the same PostgreSQL version, so we upgraded it before that. And package replacement was not really necessary. So all the package installation messages that we emitted in our actor were essentially a safety net to say, if that package cannot be reinstalled, your repository setup is broken. So Leapp would then forbid the upgrade instead of removing Foreman from the system, which is not what you want usually, right? You want a working system afterwards. So yeah, that's what we did, what we shortcutted, and it really helped that we have doing this second time. And this time we also learned, like, the Leapp structure, you can provide actors that are either upgrade agnostic, so it has a common folder, and an EL7 to an EL8, 8 to 9, and probably sometime soon a 9 to 10. And one of the things that we did was a refactoring to get all the code that is shared between the 7 to 8 and 8 to 9 upgrades to the common actors. So we don't have to care about them anymore, because we also kind of expect to have that next time, right? And if we can say this will probably happen again, then we are prepared. So yeah, that's it. I have two links for you. The second one is a PR that implemented the 8 to 9 upgrade. You don't have to look at it if you just want to upgrade Foreman, because it's merged and everything is fine. And the implies workflow thing is this massive workflow, which I did not want to show you. But this, like, the three colors that I also had in mind, because the blue one is that's happening on your old system, and here's a shortcut for the reporting, which like cuts back to the beginning. And then you have your upgrade phase, and then there's this short in this picture thing where the first boot is, but ours is a tad longer because our installation, like the installer takes, I don't know, a couple of minutes to run. So yeah. Yeah, and I obviously broke my presentation, but there is also not that much left of it. Thank you. Happy April. Are there any questions, or are you just scared to touch Leapp now?
Is there an option in the Leapp to delete the remains of the tool after a successful upgrade or not?
There isn't, and I would ask you not to do that, because like, if you're totally sure that everything's fine, you can. Like, there is documentation how like a post upgrade documentation from Red Hat that you should follow, which contains quite a lot of cleanup, because Leapp leaves things there just to be sure.
Yeah.
But for example, if you delete them, like log files, for example, and then open a case and submit a SOS report, I have no trace anymore that this is an upgraded system, which might or might not influence my ability to help you, right? So if everything is fine, sure, go delete it yourself, but automatically cleaning it up is not a good idea.
Okay.
Anybody else? On once, twice. Thank you, and I guess there's dinner now.
Yeah.